All right, this is our 1.8 part 1. We're solving absolute value equations. All right, once I go through this, I did a C period, and they're like, oh, I remember this from last year. This is not bad. I promise. I promise, okay? So when we're solving absolute value equations, what we need to remember, guys, an absolute value. Absolute value. When I say absolute value, what do you guys think of? Positive. Very good. Absolute value, whatever's in the absolute value, is always positive, okay? We're going to treat our absolute value equation kind of like we did our radical equations. You have to isolate, get by itself, your absolute value, right? Does everyone see right here, my absolute value is by itself? All right, so now, this is the only new step that we have to do. We're going to set up two equations and solve. We're going to set up an equation that says 2x minus 5 equals positive 3. And I have to set up an equation that says 2x minus 5 equals what? Negative 3. And then we solve. Once we solve, we go back and check. So I'm going to add 5 to both sides. I get 2x equals 8. I divide both sides by 2. And over here, I get x equals how much? 4. Over here on this side, girls, over here on this side, I'm going to add 5 to both sides. I get 2x equals what? 2. Divide both sides by 2, and I get x equals what? 1. Good. Yes, sir.
Is it never just going to be opposite of each other?
Say it again?
Is it ever just not going to be opposite of each other?
What do you mean not going to be opposite?
So you know how you got to that one, wait, never mind. I don't know what
Okay. Now, you need to go back and check. I am not asking you guys to formally write down a check and all that stuff, but watch how quickly and how easily, especially when we just whole numbers, sometimes you get fractions and it's a little harder, but when we have whole numbers, this is how I need you to check. You don't have to write it down, but if I take positive 4 and I put it in my original, what is 2 times 4? 8. 8 minus 5 is? What's the absolute value of 3? Does 3 equal 3?
Yes.
Okay, 4 works. Plug in 1. What is 2 times 1? 2. What's 2 minus 5? Negative 3. What's the absolute value of negative 3? Positive 3. So does x equal 1 work? Yes, you're good. Is it going to work every single time? No. All right, and we'll show you when it doesn't. Are you going to have a time when one of them works and one of them doesn't? No. What did you just say something?
I'm so lost. I don't understand.
With what part?
What do we, what is it? You have to just put it negative?
Yes, because, all right, let's do the next one. This one's pretty quick. Isolate is my absolute value by itself? Yes or no? Yes, okay, so I say 5x equals what? 20, and I say 5x equals what? Negative 20. So solve both of them. Divide both sides by 5, and on the left-hand side here, I get x equals how much? 4. On the right-hand side, divide by 5, and I get x equals how much? Negative 4. Now I need to go back and check. You guys can do this in your head. Put positive 4 into the original. What's 5 times 4? What's the absolute value of 20? Okay, we're good to go. Plug in negative 4. What's 5 times negative 4? Negative 20. Well, what's the absolute value of negative 20? Positive 20. We're good to go. Questions? Isolate your absolute value, sorry. So I say, all right, negative 3x equals positive 10, and negative 3x equals what? Negative 10, all right? Divide both sides by negative 3. I get x equals negative 10 thirds. Divide both sides by negative 3, and I get x equals positive 10 thirds. Now, you will get fractions. You'll get fractions on your web assigned homework. You'll get fractions on your quiz. That's okay. I know you guys freak out, but watch. I'm going to write this check down so you can see it a little better. I have the absolute value of negative 3 times negative 10 over 3 equals 10. Now, think about this. There's two ways you can look at this. This negative 3 is over 1, right? So you can multiply your numerator. Get negative times negative is positive 30 over 3, right? Which simplifies to 10. I saw the fly. I saw it. right? You can multiply the numerators and get 30 over 3, which would simplify to 10. Or you can look at this and say, I have a 3 on top and a 3 on the bottom, right? And then a negative times a negative is a positive. So what's the absolute value of 10?
10.
Okay, so this one works. Now do the same thing, and you're going to plug in 10 over 3. I'm just going to use the same problem here. So when I multiply this across, I have negative 3 times 10 over 3. Well, this just becomes negative 10. What's the absolute value of negative 10? 10. So we're good. They both work. Fractions are not horrific to plug in, but you have to actually plug them in. Yes.
So it's not going to work sometimes?
Mm-hmm.
Then it's not.
We'll get you. I'll show you where. All right, let's look at number 4, right? These are going to get a tad bit more complicated just in the solving of the equation, but nothing you guys can't handle. I need to get that x by itself. What are the two things that are going on the left-hand side of the equal sign? What? We're multiplying by 5. Good. And adding 3. Some of you on your test and your quiz, if there was a number in front of your radical, you subtracted it. Guys, that says 5 times. What's the opposite of 5 times? Divided by. So the first thing we're going to do is subtract 3 from both sides. Remember, we cannot set our two equations until your absolute value is completely by itself. Now I'm going to divide both sides by what? 5. So I get the absolute, whoops, those are tiny absolute value. The absolute value of x equals 5. Well, this one's real easy to do. My two equations are x equals positive 5 and x equals what? Negative 5. So quickly, in your head, you guys can do this. In your original, plug it back into the original. If I put in positive 5, what is the absolute value of positive 5? 5 times 5. 25 plus 3. 28. Oh, good. That one works. Now plug in negative 5. What's the absolute value of negative 5? 5 times 5 is plus 3. Perfect. This one works as well. Questions? You guys notice on number 7, on your number 7 looks a tad bit different than mine. What do you need to change on your number 7?
Negative.
Make, on number 7, make 11 negative. I'll show you why in a second, but there's a reason why I'll show you. All right, here we go. Number 5, we're going to isolate our absolute value bars. Well, they already are. So I rewrite my two equations. One is x minus 3 equals positive 2. What's the other one? X minus 3 equals negative 2. Perfect. So as we go to solve, guys, I'm going to add 3 to both sides. So on the left-hand side, I get x equals 5. Perfect. On the right-hand side, okay, I'm going to add 3, right? Add 3. I get x equals 1. When you solve these two separate equations, should you ever get the same answer? Okay, so just make sure of that because that means you forgot to flip the sign. So plug 5 back in, put it into the original. 5 minus 3 is 2. What's the absolute value of 2?
2.
Does 2 equal 2?
Yes.
Sweet. Plug 1. What's 1 minus 3? What's the absolute value of negative 2?
2.
Does 2 equal 2? Good to go. Do we like these?
Yeah.
Yeah, they're not bad. Kind of fun? A little bit? This is a fun Friday, guys. Fun Friday. Fun Friday. Absolute value. Isolate your absolute value. How do I set this up? What do I do? 2x minus 3 equals positive 7. 2x minus 3 equals negative 7. Great. Now when you go to solve, you're going to do the same thing on both sides. We're going to add 3. Add 3. I get 2x equals 10. Divide by 2, and I get x equals what?
5.
X equals 5. Good. On the right-hand side, we're going to, again, add 3. But now I have negative 7 plus 3. So I have 2x equals, what's negative 7 plus 3? Negative 4. Good. Divide both sides by 2, and I get x equals negative 2. All right. Now, in your head, in your brain, you guys can do this. Plug back 5 into your original. What is 2 times 5?
7.
Minus 3.
7.
What's the absolute value? 7.
7.
Good to go. Negative 2. What's 2 times negative 2? Negative 4 minus 3. Absolute value of negative 7. We're good to go. Awesome. All right, now you guys are like, does this work all the time? Of course not. Some of you are going to see, oh, I see. As soon as I see this certain thing, I can say no solution. Some of you are not going to see that. That is okay. You just solve these equations exactly like you should every single time, and you'll see when it's no solution, when it's not. Is my absolute value isolated? Okay, it's all by itself, right? So I have 2x, whoops, not equals. 2x minus 3 equals negative 11. And then what do I have to say? 2x minus 3 equals positive 11. All right, so we're going to add 3 to both sides. 2x equals what? Negative 8. Divide by 2, I get x equals negative 4. Good. Right-hand side, add 3 to both sides. I get 2x equals 14. Divide both sides by 2, and I get x equals what? 7. Now, here is why you have to check, guys. I'm going to plug back in. I'm going to actually work it out below so you guys can see. When I plug back in negative 4, do you guys agree with me? Negative 4 times 2 is negative 8 minus 3, right? So I have on the left-hand side the absolute value of negative 11 equals negative 11. Is that a true statement? Why not? Because the absolute value of negative 11 is positive 11. So this is not a true statement. Does negative 4 work? No. All right, let's try 7. 7's positive. Maybe that'll work. So I have the absolute value of 2 times 7 is 14 minus 3. Does that give me negative 11? Well, what's 14 minus 3? Does the absolute value of 11 equal negative 11? No, it does not. So what is my answer here? No solution. Yes, ma'am.
So we automatically see a negative in the answer. We just automatically see the
Okay, here is my, I like that you're seeing that. Here's my problem with that. A lot of times, it's no solution, guys. Now listen to me. It's no solution when once you have your absolute value isolated. Do you see how this is isolated? Once you have absolute value by itself, and it's set equal to a negative number, it's no solution. The problem is, sometimes you guys will see something like this. Like, don't change your answer. I mean, don't change your problem, but sometimes you'll see something like this. And people go, oh, absolute values on one side, negatives on the other, it's no solution. Is that true? No. Just because it says equals a negative number does not make it no solution. When no solution occurs is once your absolute value bars are isolated and then it's set to a negative number. If you guys saw that from the very beginning, you could tell me no solution. But if I were you, just because, we're still kind of learning this and getting into the swing of things, I would just go through the motions to solve and check.
But if we have one like the other one where you still have to move numbers around and it's not isolated, once you get it isolated, do you still have to keep going?
No.
Or once you isolate it, you get
I have a couple examples like that,
so
you'll
you
see.
can be like halfway through the problem and once
Correct.
you see it's set
Yep.
to a negative number, you just say no solution.
Yep, you'll see that. But some people just like to go through the whole thing just so you don't miss anything. You know what I mean?
Okay.
Just to make sure you don't make any silly mistakes. But let's look at this one. Okay, let's look at number 8. Is my absolute value isolated yet? Guys, there's 2 things. 2 things. What are the 2 things? There's a negative 1 right here, right? Don't forget about that. And I have a positive 4. How do I get that positive 4 to move to the other side? I'm going to subtract 4. So I have negative absolute value of 3x plus 6 equals negative 3. Now, some of you are going to be like, oh, look, absolute value set equal to a negative number. No solution. Is that true? No, because your absolute value is not isolated yet. How do I get it all by itself? I have to multiply or divide everything by negative 1. And once I do that, now my absolute value bars are isolated. But negative 3 divided by negative 1 is positive 3. So that's why I'm saying I don't want you to make careless mistakes because you see negative numbers. But there are situations where once you isolate it, if it's set equal to a negative, you can stop and say no solution. But here we're going to say 3x plus 6 equals positive 3. And 3x plus 6 equals negative 3. Agreed? Okay, so let's go through the process of solving. We're going to subtract 6 from both sides. So 3x equals negative 3. Divide by 3, and I get x equals negative 1. And then on the right, we're going to subtract 6 from both sides. We get 3x equals negative 9. Divide by 3, and you get x equals negative 3, right? So go back to your original. It's going to take a little more brain power, but that's okay. Listen to me. Answer my questions as I say them out loud. If I plug in negative 1, what is 3 times negative 1? Negative 3 plus 6. Positive 3. All right. What's the absolute value of 3? 3. Absolute value of 3 is 3. And then 4 minus 3 equals 1. Okay? This one works. Let me finish this problem and then I'll show you. A lot of times we don't know what that means. Hold on. Plug in negative 3. What's 3 times negative 3? Negative 9 plus 6. Negative 3. What's the absolute value of negative 3? Positive 3. And then what's 4 minus 3? 1.
Wait, didn't you just say that it's not the opposite sign?
This worked out to be the absolute value of negative 3 is what? Positive 3. Absolute value is always positive. The absolute value of negative 3 is 3.
Oh, so if it was
The absolute value of 3 is 3.
okay.
Let me show you real quick. Hang on, Kara. Absolute value. Okay. Here's 0. Little sidebar here. Here's positive 3. Here's negative 3. Absolute value, by definition, is the distance a number is away from 0 on a number line. From 0 on a number line. Okay, so how many spaces, that's what absolute value is. It's counting the spaces that a number is away from 0. So positive 3. Doesn't matter the direction. How many spaces do I count? 1, 2, 3, right? It's 3 spaces. You guys agree? Well, how far is negative 3? It's 1, 2, 3 spaces, right? All absolute value is it counts the spaces away from 0 that a number is on a number line. The negative and the positive is the direction that it goes. But the distance from 0 to that number is your absolute value. And do we ever measure distance in negative numbers? No, so that's why it's positive. Okay, let's go over the check, okay? Let's go over the check because this one's a little lengthy and I want you guys to make sure that you understand how to check. So if we're checking number 8, all right, I'm going to plug in negative 1 first. So I have 4 minus the absolute value of 3 times negative 1 plus 6. Does that equal 1? So we simplify from the inside out. So I have 4 minus the absolute value. What is 3 times negative 1? Negative 3, right? Plus 6. So then I have 4 minus. What is negative 3 plus 6? 3. The absolute value of 3 is what?
3.
So 4 minus 3 equals 1? Okay, we're good. So now we're going to check negative 3. So we're going to do the same thing. 4 minus, we have the absolute value of 3 times negative 3 plus 6 equals 1. So simplify from the inside out. 3 times negative 3 is negative 9 plus 6 equals 1. 4 minus the absolute value of negative 3 equals 1. What's the absolute value of negative 3?
3.
Positive 3. So 4 minus 3 equals 1. Yep. All right. Well, let's move along. Is my absolute value by itself? No, it's not. So let's isolate it. Let's get it all by itself. I have to do 2 things before I can set my equations equal to positive and negative 15. Kara, tell me what to do.
Divide by 3 and minus 6.
Okay, we're going to minus 6 first, and then 3, and then x plus 5 equals 15 minus 6 is 9. Then we're going to divide by 3. So I get x plus 5 equals what? 3. You guys know PEMDAS, right? When we're simplifying? When you're solving, you know you do the backwards of PEMDAS, right? SADMEP. You guys ever heard that? Okay. All right. Look, this is PEMDAS backwards. SADMEP. We got all these little side lessons today. SADMEP. When you're solving an equation, right? You're trying to get x by itself. You do PEMDAS backwards. So you get rid of, what's S and A? Subtraction and addition. Get rid of that first. You see how we at minus the 6?
Forwards that I think of.
That's fine. And then what is the D and the M? Division multiplication. So when you're solving an equation, trying to get x by itself, you do the opposite of PEMDAS. So you get rid of subtraction and addition first, then you divide or multiply. All these teachable moments today. This is good. This is good. I like it. All right, so now guys, if I'm going to solve this, I have x plus 5 equals 3 and x plus 5 equals negative 3. Agreed? Okay, so solve. Minus 5 from both sides. X equals negative 2. And over here, I'm going to minus 5 from both sides. And x equals negative 8. Now, I'll go through the whole check. 3, and then we have negative 2 plus 5 plus 6. Does that equal 15? Well, what's negative 2 plus 5? 3. The absolute value of 3 is 3 times 3 is, and 9 plus 6 is good to go. All right, same thing. Absolute value negative 8 plus 5 plus 6 equals 15. What is negative 8 plus 5? Negative 3. Well, what's the absolute value of negative 3? 3. 3 times 3 is 9 plus 6 is good to go. No worries, no worries. All right, let's look at this one. What do we need to do? I got to isolate this. Let's move 20 to the other side. So I have the absolute value of 2x minus 4 equals negative 5. No solution. And some of you are like, what? How am I supposed to know that? You don't have to. Keep going. Is my absolute value, if you saw that right here, because your absolute value, what's inside of your absolute value cannot be negative. It can't, the value, the entire inside value will not be equal to a negative number. But if you don't see that right here, keep going. No worries. You have 2x minus 4 equals negative 5. And 2x minus 4 equals positive 5. So I'm going to add 4 to both sides. 2x equals negative 1, right? Divide by 2, and I get x equals negative 1/2. Over here, we're going to add 4 to both sides. 2x equals 9. Divide both sides by 2, and you get x equals 9 over 2. Right? Okay, so if I go up here to check this, and this is where you guys have to, this is why checking is important. If I go up to check this, this is why you have 20 plus, I have the absolute value of 2 times negative 1/2 minus 4 equals 15, right? Okay, well, let's simplify from the inside out. 2 times negative 1/2, right? These 2's cancel. So you have negative 1 minus 4 is what? Negative 1 minus 4. Negative 5. So look, guys, this says 20 plus the absolute value of negative 5 equals 15. Some of you will look at that and go, but Miss Meadows, 20 minus 5 is 15. What is the absolute value of negative 5? 5. So what this problem says is 20 plus 5 equals 15. Is that true? No. The same thing happens when you plug in 9 over 2. Because when you plug in 9 over 2, the 2's cancel out. You have 9 minus 4 is 5. What's 20 plus 5? 25, not 15. So this one doesn't work either. So your answer here would be no solution. But again, if you saw at this point right here that your absolute value was isolated and it was set equal to a negative number, at this point right here, you could tell me no solution. If you don't see it, if you forget that, if you're still a little like, oh, I don't know, then go through with the whole problem. It's no big deal. Not a big deal at all. All right, we're good? All right, everybody's web assign has a question that looks like this. All right, when we had radicals that were the same, right, we had square root and square root on both sides. We just squared both sides, correct? Okay, if this is kind of the same like concept, but with this, we're going to do the exact same thing that we just did before. what we did before is we isolated our radicals, right? And then we rewrote our equations twice. One with a positive answer, one with a negative answer, right? We're going to do the same thing. Are my radicals isolated? They are, right? There's nothing. So I'm going to rewrite this as x minus 1 equals positive 3x plus 2. I'm just putting this so you guys can see it. You don't have to write this. And then I have to write an equation that says x minus 1 equals what? Negative 3x plus 2. Now, Olivia was looking at that and she was thinking, well, it's going to be negative 3x minus 2. If you see that in your head right away, that's fine. You have to change the signs of everything. The reason I put it into parentheses is because what do I have to do with this negative? I have to distribute it. So on this side, I have x minus 1 equals 3x plus 2. And over here, I have x minus 1 equals negative 3x minus 2. God bless you. You're making one side positive, one side. I have tissues there if you want them a little nicer on your nose.
You could just write it.
From the beginning, if you saw that you needed it to be negative 3x minus 2, yeah. So let's just solve. Move x's to one side. Numbers to the others. You guys are going to say, does it matter which side I move them to? No, it doesn't matter. But when we do inequalities, where do we like to have our variables? On the left. So I would get in the habit of just moving to the left. So on the left-hand side, I have negative 2x equals 3, right? Divide both sides by negative 2. And I get x equals negative 3 over 2. And then over here, I'm going to do the same thing. Now I'm going to add 3x to both sides and add 1. And I get 4x equals negative 1. Divide by 4, and I get x equals negative 1/4. Yes, is it going to be super easy to check? It's not horrible, but it's not like the most fun thing we could do today. But let's check. I have absolute value of x minus 1 equals the absolute value of 3x plus 2. All right, so we're going to plug in negative 3/2. So I have negative 3 over 2. I'm going to change 1 to 2s, to seconds. What does it become? 2 over 2. Okay, good. So what's negative 3 over 2 minus 2 over 2? 3 minus 2 is, negative 3 minus 2 is... Okay, negative 5 over 2. Now over here, I have the absolute value of 3 times, right, negative 3 over 2, plus, I'm going to change 2 over 1 to seconds. This becomes 4 over 2, right? So this becomes negative 9 over 2 plus 4 over 2 gives me what? Negative 5 over 2. Are these the same? Are they the same? Yes.
You did a lot of stuff.
I changed 2 over 1 to 4 over 2. I changed 1 over 1 to 2 over 2. That's it. We're going to do the same thing with fourths, right? Change it to a decimal then. What's fourths?
Okay, so but do you have to change it at all? Like, or
Hi.
can you leave it how it?
Yeah, of course. All right, let's plug in negative 1/4. So I have x minus 1. And then we did 3 over 2. All right, look. I know you guys don't like fractions. It's okay. Let's plug in negative 1/4. So I'm going to say negative 1/4 minus 1, right? I'm just plugging negative 1/4 minus 1. I can change the whole number 1 to what over what to make it fourths? Just 4 over what? 4 over 4. So negative 1 minus 4 gives me negative 5 over 4. Okay, on this side, I have 3 times negative 1/4 plus 2. So I have negative 3/4 plus 2. Whoops. If I change 2 over 1, guys, to fourths, what does it become? 8 over 4. So I have negative 3 over 4 plus 8 over 4. What's negative 3 plus 8? Negative 5/4. Does negative 5/4 equal negative 5/4? Yes, so you're good. You guys have got to become a little more comfortable with fractions. You have to. I know it's scary. There's a lot scarier things in life than fractions. I can assure you of that.
Yeah, I don't know about all that.
All right, are both of my absolute value bars isolated? Yes. So I'm just going to rewrite this as x plus 3 equals positive 2x plus 1. And then I have x plus 3 equals negative 2x plus 1, which would become negative 2x minus 1. Right? It's negative 2x plus 1, and we have to distribute the negative. You can write it either way. You just got to make sure you distribute the negative. So on the left-hand side, I'm going to subtract 2x, and then I'm going to subtract 3. So I get negative x equals what? Negative 2? 1 minus 3? Right? Negative 2? Divide both sides by negative 1. I get x equals 2. Not a fraction, Reese. Now over here, I'm going to add 2x to both sides. So add 2x. And then I'm going to subtract 3. So I have 3x equals what? Negative 4. Divide by 3, and I get x equals negative 4/3. And those are my two answers. Plug them back in, and they will work beautifully. Questions?